Good evening, ladies and gentlemen. It's my again pleasure to invite you all for the plenary session 3 on disruptive technologies. I invite the chairman of this session, Dr. Arun Jaura, Managing Director, Michelin India Technology Center, on the dais. And the speakers of this session, Mr. Dan Nicholson, Vice President of General Motors, United States, Dr. Thomas Hulshorst, Vice President, FEV, Germany. Let's give a big round of applause for the chairman and the speakers of this session. And it's my great honor to introduce Dr. Arun Jaura, Managing Director, Michelin India Technology Center. Dr. Jaura leads the operations of Michelin India Technology Center, which is responsible for research and development work for truck and bus tires for Africa, Middle East, India, Asia, and China. Michelin India Technology Center is a part of Michelin Worldwide R&D Network. Dr. Jaura has over 3 decades of rich experience in diverse industry sectors. Prior to joining Michelin, he has held several leadership roles in companies such as Traction, SAE International, Eaton, Mahindra & Mahindra, and Ford Motor Company, among others. He is currently a member of the National Board of Electric Mobility in India. He was also the board of director in SAE International in the US and a member of European Advisory Committee for SAE International. Dr. Jaura is the 2004 recipient of the prestigious Henry Ford Technical Achievement Award from Ford in Michigan. He is also a SAE Technical Fellow. Dr. Jaura is a co-inventor of 5 patents filed in the United States, Japan, and Europe, and has more than 30 referred technical papers in international journals and conferences. He has a PhD in artificial intelligence used for robotic assembly using artificial intelligence. He obtained his master's in technology from IIT Madras. Ladies and gentlemen, let's give a big round of applause to the chairman of this session, Dr. Jaura, the podium to you.
Good afternoon, and I'm really delighted to be here chairing this plenary session, the last one of the day. We have very eminent speakers here along with me here on the dais. It gives me pleasure to introduce Dan Nicholson, who was appointed with General Motors. He is the Vice President of Global Propulsion Products, including engines, transmissions, fuel cells, electric drive units, and batteries. Prior to that, Dan was the Executive Director for Global Powertrain Embedded Controls at General Motors. In that role, Dan ran the day-to-day operations of the global engineering team responsible for all powertrain controllers and software, as well as powertrain calibration. Dan began his career with General Motors as a co-op student at the Buick Motor Division in 1982. He has an extensive background in product engineering and subsequently progressed through a series of leadership positions, including engineering group manager, director of controller integration, director of engine calibration, chief engineer for the V8 engines, managing director of GM Powertrain Germany, where he had led all powertrain operations for the country unit and also the vice president of global quality. Dan earned a Bachelor's of Science degree in Mechanical Engineering from General Motors Institute. Now it's called the Kettering University. I'm sure all of you know that. A Master of Science degree in Mechanical Engineering from Texas A&M University, and a Master of Business Administration degree from Stanford University. Dan is a registered professional engineer in the state of Michigan. He is an SAE Fellow and is the president of FISITA, chair of the trustees for the SAE Foundation, and president of the Engineering Society of Detroit. I'll also take a minute to introduce the other speaker here with us on the dais. Dr. Thomas Hulshorst. Dr. Thomas has taken over as the global management of the Electronic and Electrification Business Unit. Since joining FEV in 2002, Dr. Thomas has played a key role in the advancement of Electrification and Electronics Business Unit. In addition to the expansion of FEV's competencies in electric mobility, battery development, and vehicle electronics. He has been heavily involved with FEV software for controlling hybrids and electric drives and the FEV battery management systems. Dr. Thomas has launched the new smart vehicle engineering as an interdisciplinary and comprehensive approach to intelligent, connected, and automated vehicles. Dan will be speaking on electric mobility, and Dr. Thomas will be speaking on connected and autonomous driving vehicles. So I will invite Dan to please take the stage.
Good afternoon. Good afternoon. Okay, no sleeping. First, thank you, Dr. Bharadwaj, for asking me to present during this session. The session title of Electric Mobility is as broad-ranging as the globe itself. There are regional, national, state, and yes, even city facets that play into this statement. A short 20-minute session cannot cover all of these areas, let alone the global aspect that overarches all of them. However, let me try to lend some clarification and maybe even add to your understanding of General Motors' commitment to zero crashes, zero emissions, and zero congestion, and how it ties into electric mobility. As the saying goes, the fun is in the journey, not necessarily in the end itself. I would venture to say that some of Bill Gates's fondest memories will not be built upon the moment he hit $100 billion in personal net worth, but rather the road and the milestones he achieved on the way to get there. Likewise, with General Motors, an emissions-free world is our vision, one that the entire company wholeheartedly embraces. It is a bold endeavor and a journey where electrification will play a critical role. However, on our journey to get there, we are not leaving anything on the table that can help reduce emissions. And we know that some of the biggest enablers to those reductions are within our reach in the very near term. In fact, we're doing it now. Part of understanding electrification is understanding how it must live harmoniously with non-electric mobility for the time being. Without this clear understanding, we and society will not maximize our ability to reduce emissions. We are in the era of peaceful coexistence. Think for a moment, if we stopped developing the internal combustion engine and instead focused all our efforts on electrification and electrification only. The advances we are making with the internal combustion engine would stop. Would we really want that? Would the most ardent supporter for reduced CO2 emissions want that? No one should want this, because on a regular basis, we are stretching the efficiency of the internal combustion engine beyond what was thought achievable a decade ago. Within the last year, we've introduced a technology called dynamic fuel management that seamlessly runs on only the number of cylinders needed between 0 to 8 for a V8 engine. Is this a niche, low-volume engine? No. In fact, it is one of our highest-selling engines globally. In addition, we're rolling out an all-new 2.7-liter turbo engine with cylinder deactivation enabled by an industry-first tri-power valve train that enables different valve modes to maximize efficiency. It has high lift, low lift, and no lift. Let me try to read your mind. Some of you may be saying to yourselves, the theme is supposed to be about electric mobility. What does that have to do with engines? Let me tie it together. We all would like to see a world with zero mobility emissions, right? This is a journey, and it is a marathon, not a sprint. We shouldn't and actually cannot prescribe how we get there. We must keep in mind that the road to get there is going to be paved with internal combustion engines, including more turbocharged downsizing, and the more efficient those become, the closer and more quickly we will get to the end goal we all want. Whether here or in Europe, in South America, in China, or in the United States. The more efficient an internal combustion engine becomes, changes our outlook on the capability of the internal combustion engine and the significance it has on overall emissions in comparison or in complement to that already being achieved by our electric vehicle programs. As one gets better, it challenges the benchmark of the other. Please don't get me wrong. At General Motors, we love our Bolt electric vehicle, and our customers love their Bolt EV even more. In terms of an engineering feat, we are very proud of the Bolt and the 238-mile electric range that it has. But as much as we love the accolades it receives, the amount that it moves the needle towards zero emissions simply pales at this time compared to significant high-volume internal combustion engine improvements in terms of the overall fleet CO2 reduction. Does this mean we have a proclivity toward developing internal combustion engines and not electrification? I hope no one thinks that. What we need the world to clearly understand now more than ever, and this includes customers, engineers, academia, and even investors, is that we're in a time when peaceful coexistence between the internal combustion engine and electrification is not only necessary, it is part of the solution to reach zero emissions. GM believes the future of personal mobility will be driven by the convergence of improved internal combustion engines, electrification, autonomous vehicle operation, connectivity, and shared mobility services. This convergence of technologies will drive the transformation of personal mobility and the entire automotive and mobility industry. And at GM, we are not just affected by these rapid changes in our industry, but in fact, we are helping to drive them. While we continue to grow and improve our core business of building and selling great cars, trucks, and crossovers and SUVs, we are also rapidly adopting new technologies that move us further along on our journey. And it is just that, a journey. GM's Global Propulsion Systems has been very active in both improving current technologies that are part of today's core business, as well as adapting new technologies. This means that while we look ahead to the rapidly evolving future of the automotive industry, we can't lose sight of how important it is to continue providing our customers fuel-efficient solutions today. Please consider the recently published Energy Information Agency 2018 Annual Energy Outlook. The EIA is projecting that gasoline vehicles remain the dominant vehicle type through 2050, although the alternative propulsion market share does grow. I am not endorsing this view. I am merely presenting it. For this reason, GM continues to innovate in the area of internal combustion engines to deliver on fuel economy goals and to continue to deliver reduced emissions in an affordable manner. Internal combustion engine efficiency improvements are an important part of our journey to zero emissions. So, to tie this into the theme, please consider that the internal combustion engine and electrification families are planning to live together for the foreseeable future. They can be good neighbors, good friends, and peacefully coexist for the benefit of all society. And that would be a true positive change for all mankind. Thank you for your kind attention.
So, Dr. Jaura, many thanks for the kind introduction. So, my name is Hulshorst from FEV. I'm responsible in the group for electronics and electrification. This is a kind of an old-fashioned name for what we today would call the CASE, so connected, automated, shared, and electrified. So, for today, I would like to give you an overview about, I would say, some disruptive technologies we see, and even if the headline is connectivity, I also added some autonomous stuff because it's merging together more and more, so it's very hard to separate connectivity from autonomous driving. So I would like to start with a brief introduction, then I will go to the market forecast. Mainly I will talk about use cases. So honestly, I do not like that much to talk about autonomous driving. So somebody told me it's not possible to bring autonomous driving to Indian roads. So, okay, which use case we're talking about? So we should not talk about autonomous driving, we should talk about use cases. So I have some examples with me. And finally, I would like to finalize with a summary. Okay, so the connected car environment is driving on a network. So that's what we see already coming. It's already honestly in place. So I'm already driving connected cars in 6 years. And honestly, I'm getting nervous if my car is not connected nowadays. And I am starting freeing around with my mobile phone instead. So of course, the question is, what are the key sectors? And we are not only talking about individual transportation, which will remain the majority of the market share, but the share of car sharing, e-hailing is increasing. We should also talk about public transportation, even commercial vehicles, emergency vehicles, and even farming, agriculture. So the question is to bring this to reality, so when it will happen. So sometimes it helps to look back when you're not crystal clear about the future. So for example, some time ago in 1900, so that is a picture of the Fifth Avenue in New York City. So what you see here is just one single car. A lot of horses, one single car. This is the same Fifth Avenue in New York City, just 13 years later, just 13 years, and you just see one single horse. So that's something I would like to also mention. Sometimes it's more easy to predict the future when you look back. Okay, talking about market forecast. So I would say in general, we have these 4 elements. And again, these 4 elements belong together. So connected, automated, shared, and electric. And Mr. Setcher of Daimler, he nailed it really to the point, mentioning, okay, all of these technologies have the potential to turn off our industry on its head, but the real benefit is to bring these technologies together and to make it a new added value to the driver. Okay, so the new mobility concepts will come also, of course, with new technologies, with social trends, and also will push autonomous driving. So when we do this kind of market predictions, we always have 2 models in place. One is regarding the technology push, for example, considering legislation, whatever state-of-the-art technology. On the other hand, we also consider the market pull, so what really the people would like to buy. So the OEMs that could produce very nice cars, but if the customer is not ready to pay for it, so it's more or less useless. So The technology we already mentioned, going into the electrification, and I'm not only talking about the pure EVs, I'm completely with you, Mr. Nicholson. We will have a wide diversity of powertrains, starting with the 12-volt start-stop micro-hybrid up to the full EV. We will have diverse powertrains, but we will have also increasing amount of automation connectivity because of the society's changing. So for example, I have 2 sons at the age of 20 roughly, so they're not asking for an individual car, they're more asking for a mobility flat rate. And most of the time they're looking at me when they mention that. Okay, so this is the new digital natives. They don't think anymore that the car is the coolest thing you can get, they just want to have mobility. And that's something we need to place also with the increasing share of car sharing, e-hailing. So we already know the Ubers and the lifts. In India, Ola Cabs is also very successful. That's also something we need to take into account. And at the end of the day, we need to take the consequences. So we will have to configure our future vehicles fitting to this. Very briefly regarding autonomous driving. So we have, of course, the several levels of automation. Let's skip the level 2 or the level, start with the level 3. And I simplified it a little bit. So level 3 for me means it's something, somewhere, sometimes. So some partly automated driving, somewhere and sometimes. When it comes to level 4, it's already everything. So level 4 is already autonomous driving car, but somewhere and sometimes. So limited boundary conditions, geofenced areas. Okay, stop during heavy rain, okay? And finally, and that's the really holy grail, is the level 5, which really means everything, every time, everywhere. But honestly, also from an economical point of view, I doubt that this is really something we will see within the next 10 years. But still, we will go far already with level 3 and level 4. Okay, some use cases and core technologies. Let me start with some maybe boring stuff. So we are talking about connectivity. We need to connect. So we need to connect the car with other cars. We need to connect the car with the infrastructure. We need to connect the car with the network, with the internet, with the cloud services. And even we need to connect the car probably with the pedestrians. So by doing that, we have some technologies in place we can use. For example, we can go for the 802.11p, which is based on simply Wi-Fi technology, which was modified to fit to automotive requirements. And on the other hand, of course, we have our cellular net. So today it's LTE, it's 4G, already doing a lot, impressive stuff, and 5G to come. So that's what we are talking about. Just let's talk about how we communicate. So we can communicate using the indirect mode. So that means that we will always use to go over, so which one was the laser pointer? Okay, that's the wrong one. Okay, sorry. Okay, if we go with the indirect mode, we always need to have a cellular network. So if there's no net, there's no connection. So that's not the right thing we need to have for safety-relevant features. So for safety-relevant features, I really need to have a peer-to-peer reliable communication. So that might be, for example, DSRC, which is the standard nowadays in the US, so dedicated short-range communication, which is mainly based on the Wi-Fi standard mentioned before. Or we can even use the 5G for cellular vehicle-to-X connections. So do we really need to wait for 5G? So what will 5G bring? So 5G will just bring 1 or 2 really, I would say, killing features. So this is to break down the latency to just 1 millisecond. So this is really a breakthrough. And also regarding the connection density in devices per square kilometer, we will have also a factor of 10, which is impressive. So if everything will be connected, maybe even your toaster will be connected 2 years ago. So we need to have a very high density. And that's also what brings 5G and, of course, much higher bandwidth. That's also something we're waiting for. So when we joined the 5G AA, which is a consortium working on automotive applications of 5G, so FAV is a member, we also started doing a kind of a use case evaluation. So we just started with this matrix approach, understanding so what could be done, which new features using 5G technology, and we ranked this accordingly to the benefit to the user. And what you can see here is that already a lot of these features you can apply even with 4G, even today. So a very simple example is a speed limit. So you can, the speed limit warning directly addressed by infrastructure to car communication. But even more benefit will bring to the customer, for example, platooning, supported by connectivity, or connected adaptive cruise control. But let's talk about a real future star using 5G technology. It's just one simple example. It's just one single use case I would like to highlight. We called it the remote-controlled autonomous vehicle. So let me directly go to one use case. So let's imagine there's a smart city with dedicated lanes for autonomous driving cars only. So limited boundary conditions, and these cars are designed to be extremely safe, extremely passive. So that means if anything will occur which this car is not trained for, it will simply stop. So that's the use case. So we see here the dedicated lanes where we have this autonomous vehicles running. There's the other lane where the conventional cars are running. So, but maybe there will be one situation occur. There's an object on the road. So one of the cars is blocked. And there's one guy sitting, he's connected to the fleet of autonomous driving cars. He will be alarmed. So one car is blocked. Then he can directly log into the car. He see what is the problem. Oh, there's an object on the road. How to deal with that? Based on the information he can get using 5G, he can also decide what to do. He will wait until the traffic is limited, and then he can simply take over the control of the car and pass the object on the road. So this is a very simple use case, just also bringing some new ideas to the table, that it's not always necessary that the autonomous driving cars really need to deal with every single situation. Okay, after the object was passed, we can switch to normal mode. Okay, this use case, of course, will require that we will have real-time video streams, that we have audio communication, so the passengers need to be informed about the situation. We need to get information about the car sensors, access to the actuators. So, of course, also in regard of functional safety, this is really, I would say, a little bit fantastic. But okay, we will see what will happen. Let's go to another use case, which is a new design car. It's called Sven, Shared Vehicle Electric Native. So the engineering is done by FEV, so we have a strong relationship to this company. It's one of the famous startups from Aachen region, so maybe you also know some other examples. So this car was really designed to be shared. So it's easy to clean, it's easy to be repaired, whatever happens. And also the connectivity concept is designed to really fit to this purpose. So you can do the car reservation during you're waiting for your suitcase at the Belt at the airport. Then while you will still waiting for your suitcase, the car will already come from the parking section to a pickup station, which is nearest to your location in the airport. So the car will wait for you, will come to you instead that you would need to go there. And then, of course, just using your mobile phone app, just pay, unlock the door, and just let's go. So there's another very impressive example we are working on together with our partner in Turkey. It's Codeco. So this program is also supported by TÜBİTAK. So it's about an autonomous electric campus shuttle. So again, geofenced area, so it's a predicted area. It's not the city of Chennai, it's a predicted area. And it's a four-seater, it's a semi-open body architecture, it's automatic doors, interaction screen involved, a fully electric drivetrain. So the seat reservation and payment is done by the app. Autonomous driving without the driver even. steering wheel is not in place. And also it's just for this closed campus area. Let's have a very short view on the video. What do I need to stop to start the video? Like that. So the car is called Automod, automated pod. Okay, so maybe that's not the first time that you have seen something similar, but I would like to highlight this is not US, that's not Europe, or it's part of Europe, it's in Turkey, and we are doing this with our Turkey team. So we have a smart vehicles team in Turkey working on this with global support, because that's also, I would say, part of the story, part of the truth. If we go with new technologies, we also need to find the smart talents, and the smart talents are difficult to find, and so we really go where our talents are, and Turkey is a good place for that. So this is another example. I will very quickly go over that. That's also a car which is equipped with connectivity. It's equipped with level 4 and level 3 functions. So it's a traffic pilot. It's a highway pilot, it's a it's a self-parking feature, but just to come directly to the overview. So FAV is working on different use cases with different demonstrators, with different missions, and also with different partners. And I think that makes sense. So we started with our extended EV range electric car. So our mission was to extend the range of an EV with the same physical battery. So that was a project where we also worked together closely with Denso, so Max Nakagawa, great to see you here. And we managed to save up to 20% of energy consumption by applying connectivity to this car. But it's just a level 2, it's just a predictive cruise control. The other project I mentioned right now, the mission is to find new features for individual cars, so the cars we would like to buy. So I'm traveling a lot using my car. I would really like to have my highway pilot, valet parking, all of these features. I would pay for it, for sure. Okay, so this is what we go with this car, and in parallel we have two, I would say, more aggressive approaches. So for example, the mission for the autonomous driving campus shuttle, which is a level 4, and also the mission to go for shared mobility car, which is level 3 and level 4. Okay, when we talk about autonomous driving, very briefly, what are the core elements? Very quickly. So we already mentioned that we will have diverse vehicle applications and platforms. It's not only the individual car anymore. Then we will have a changed EE architecture. We have X-by-wire technology, which needs to be ASIL-D proof. We will have a different software architecture. We will have rule-based functions as we are used to, but if we want to go really for autonomous driving, we cannot go for so many rules, so we need to apply AI-based functions as well. So the AI-based functions, they will bring additional benefit. So for this, we'll need to have the AI framework, and at the end of the day, we need a lot of real-world data, and if we really want to have all the scenarios in place, even combined with virtual world simulated data. So this is, I would say, what I would consider to be the core elements. We need to solve this. We need to bring this together, especially regarding, for example, the tool chain for the software development. Also, still being in the automotive process, so still we are automotive. We need to be automotive grade. We need to deal with the agile V-cycle, however you call it. We need to take care about functional safety. We need to take care about cybersecurity. And at the end of the day, we will need to handle a lot of data. And that's my final point I would like to highlight. So if we talk about data, data will become, and still is, already is, a value, a real value. If you have data, you have a big value. So we have a lot of cars on the road, so we will collect a lot of data from these cars. So the cars will have a lot of data for from the system itself, also reference data, ground truths. Maybe we will even monitor the driver, we will have the metadata, we will pre-process this. So this is the FEV data management ecosystem. We set this up already 2 years ago, and still we are working on that. It's a massive, tremendous work which needs to be done. Okay, starting with the data coming from the logger, pre-processed to be, I would say, usable. Put this in the raw data server, but of course we would like to use it from everywhere, so let's put it in the cloud. So then let's use this data for the next step. I would like to understand which data do I have. So we have developed a tool which is doing auto labeling. So just understanding which objects are in, understanding also the situation so that we can even analyze the scenarios. So, for example, it makes no sense to collect data from the same scenario 1,000 times. Okay, you will increase the accuracy, but still it's limited to this scenario. So we want to understand, are the data we're getting from the vehicle fleet, do we cover all the scenarios we would like to have? Okay, that's something we're doing with a tool we have developed. Then we will put the labeled data and the scenarios back to the cloud. Then we would like to train our neural networks, deep neural networks. Also, this is used, herefore we use the data, and we will put back the data we used for training, for validation, and finally, we need to do a lot of validation and testing. Also here we can use the data cloud for doing the test case generation, and then we can do the resimulation, and then we will even have the test data in place. So this is mainly what I wanted to show. This is just one example of this auto labeling tool. We can simply use a video data, and by applying also neural networks, deep neural networks, we can already, with a quite good coverage, identify which objects are in. We can classify the objects, and so far we reached, of course, depending on the scenery, up to 70 to 80% coverage. And then still there are some unlucky guys sitting there checking and still drawing boxes, but this amount is reduced. Just to give you some idea, if we're talking about a level 3 function, we're talking about 3 billion of frames. So each frame to be analyzed manually by a human being will take 19 minutes in average to understand the situations, to detect all of the elements. So that's what we are talking about, and we can reduce this by 80%, so that's already something which really brings benefit. Then my final slide is about another topic. It's about smart cities. So this is a project FIV is doing for Jaworzno. Jaworzno is a city in Poland which is extremely active in the field of autonomous driving. They want to become the first smart city supporting autonomous driving. So what we did, we simply scanned the city of Jaworzno. So by doing that, we used the Velodyne sensors. The city was closed for one day, and we just drove around and collected this data and just to have these additional features. Okay, then I would like to end up with a quite good statement of Henry Ford. So if you always do what you've always done, you will always get what you've always got. So that's very true. So if we want to have something new, we need to change in what we do and how we do things. And we just started already. And that's my main message for today. Thank you for your attention.
Thank you, Dan. Thank you, Thomas. I think, in light of the recent global mobility summit that we had in India a few weeks ago, this is a very apt session and a very apt discussion. And what you presented, Dan and Thomas, are very much connected to that, because we talked about electric mobility, we talked about shared mobility, we talked about connectivity, and many topics like that. And actually, I would say not only topics but initiatives. Companies like Mahindra, Toyota, Maruti, and Suzuki, they actually announced their commitment and what they want to do in terms of this mobility system, ecosystem. So Dan, question for you. With the canvas of experiences that you had over different regions, different countries that you've been in the powertrain business, also in the electric mobility business, if you were to look at India, step back and say, what are the two big things that would actually drive electric mobility in a country like India and make it mass market affordable?
Yeah, well, first I'd like to say that electrification and the switch to electric vehicles is going to happen differently around the globe. So different in countries, even within a country, very differently segment by segment. So some segments make a lot of sense, other vehicle segments make not so much sense. So in this era of peaceful coexistence, we should prepare already that it won't be homogeneous. It will be very different country and segment by segment. I'm not an expert on the Indian market. This is my 4th trip to India, and every time I come, I have new and additional insights. So when I was traveling around this time, what occurred to me is maybe it's 2-wheel and 3-wheel vehicles that could be cost-effectively electric, and maybe not necessarily starting with 4-wheel vehicle. So I think India is a very agile place and also has a good mentality for cost effectiveness. And then also, practically speaking, to make a big impact in cities on air quality, some of these 2-stroke engine, 2-wheeled and 3-wheeled vehicles would have the biggest impact in the short term. So maybe in India, the road or the marathon toward electric vehicles starts in a different way than in some other countries in the world. Just a thought.
Thank you. Thomas, question for you. Very interesting, the autonomous campus shuttle. And I've actually seen and ridden in that in Europe in a couple of places. It's a very interesting concept. Question for you is, if I am an OEM and I am already selling enough vehicles in the diesel space, electric space, in the gasoline space, what will be the drivers for me or for an OEM to actually drive something like this, and in terms of research and development, in terms of actually having a product on the road, in terms of autonomous driving vehicles?
So that's a very good question, and I think that's not the first time that this question is asked, honestly. So we already see that the OEMs are changing their strategies towards becoming more mobility provider, just of only be vehicle supplier or vehicle OEM. So that's already ongoing. You see a lot of partnerships between the OEMs and car sharing, e-hailing companies. And of course also that has an impact on the products, how the products are developed, how the products are designed. So the question is always, for example, if we think in an extreme use case, so we will only have shared mobility, for example. Will we have less vehicles? Do we need to produce less vehicles? So the question is, yes, nowadays the individual cars, they're standing 90% of the time useless on the parking space. But if you have really car sharing, so if these cars are really used 24 hours a day, what's about the durability? Will they last for 8 years? Probably not. So at the end of the day, it's an average, probably a similar situation. Maybe it will be reduced for sure, but not that massively than we might expect.
Thank you. In the interest of the time, we'll open the floor. A question from the floor. Anybody like to ask a question, interact with the speakers? Any questions, please? Yes, please. If you don't mind, you can take one of the mics. I think there's one behind you, just behind you. Kindly introduce yourself and then ask the question, please. Thank you.
I'm Mahadevan from India Pistons. This is a question for Dr. Thomas. As Dan mentioned, India has a very large population of two-wheelers. And also in vehicle production, if you see, we have a very high percentage of two-wheelers. Also, the major cause for traffic accidents is two-wheelers, much more than four-wheelers in this country. Is autonomous mobility relevant for two-wheelers? And if so, is anybody working on it?
That's also a good question. So I think if the car or if the vehicle is a two-wheeler and will be driven autonomously, it would be at least to be a three-wheeler. But in general, the question I understood very well. So yes, we will have different kind of what we call pods, so kind of robo-taxis. So my personal opinion is that we will see more, I would say, people mover for maybe 4 to 6 people, not much more, maybe even less, maybe even 3 to 4, because the people are used to be more or less alone while driving. So if they want to have other people around, they will simply use public transportation. So I think there's even a good chance that these smaller vehicles might even become the standard for robo-taxis, maybe 2 or 3-seater. So the car I showed you for car sharing is just a 3-seater, and that's by purpose. But on the other hand, of course, the two-wheelers we see in India today are mainly, I would say, the low-cost transportation. And I doubt that that will have a massive impact going into the autonomous driving. So that's a completely different use case. It will be extremely expensive. And again, if I can, I would say, afford my two-wheeler and I'm completely free, probably I will prefer that instead of a mobility flat rate, but maybe not. Maybe I will prefer to have my mobility flat rate instead. So then I think, that's my conclusion, it's not that much that we will have autonomous driving two-wheelers, but maybe we will have a change towards flat rate mobility.
Any other questions? Yes, please.
I'm Kuti from Tata Motors. See, over the past 4 days, we've been, 2 days, we've been listening about the 4 specific drivers of change which we expect to see. Now, all these drivers are going to require large amounts of investments, huge amount of people working on these technologies to make it real. Would you think governments and private industry working together will be able to devote so much of funds required for only the mobility space at the cost of funds required by society for other forms of investment?
There's a lot of echo, actually. We didn't get the question fully. We talked about, are you talking about the public-private partnership?
No.
No.
See, these 4 themes that we talked about in the past 2 days. Are you able to hear now?
There's a lot of echo.
I'm Kuti from Tata Motors. Can you hear me now?
Yeah.
Yes.
My question is that these 4 themes that we've been talking about over the past 4 days, is going to require large amounts of funds, both in terms of investments, piece costs, and other things required in the mobility space. So this is taking away funds from society only for mobility at the cost of investments in every other sector which are required socially. Would you recommend any prioritization amongst these 4 areas on which both companies and governments should allocate funds?
Is your question with regard to electrification or autonomous or both?
All 4, shared, autonomous, electrification, and connected. All this is going to require so much of money that governments and private industry will have to decide to prioritize one day or the other. If that be the case, how do you prioritize? Question 1. But more importantly, would government and private industry have so much of funds to be diverted only towards mobility at the cost of every other sorts of investments that governments should be making?
Let me try to speak to the issue. I'm not sure whether I will give you an answer to your question, but I think we can maybe at least discuss a little bit. For sure, the way governments regulate is going to matter a lot in our journey toward improved mobility. And as I mentioned in my presentation, there's really a role for regional, national, state, and local regulations that'll matter depending on whether we're talking about shared autonomous vehicles or electric vehicles or whatever. My personal opinion is I don't think it's necessary to have, government subsidies forever, but the rules that are set up matter a lot. For example, let's talk about shared autonomous vehicles. The way cities regulate whether or not they're allowed, where they can park, whether or not they can park, or they have to continuously drive around, will have a big influence on adoption rates. Luckily in the world, there are many, many, many, many cities, and hopefully the best and most innovative ideas can be quickly adopted by other cities. This would be a really great approach for society. I believe for shared autonomous, the usage case for customers is so compelling that they wish to avoid ownership at all. And if their alternative mobility is public transportation or taxis or something else, a smart, cost-effective shared autonomous vehicle would actually be a very attractive option. And if it's really a very attractive option for customers, then investors, as you mentioned, will naturally come in to take advantage of the market. So I think governments have a very smart role to play in having a good regulatory environment to allow all the innovations from the engineers in the room and around the world to flourish. But if they're too heavy-handed, they will actually slow adoption rates for mobility. Or it could also be, if they have no regulations at all, it could create kind of other problems. So there will need to be a really good cooperation between academia, industry, and government, facilitated by organizations like FISITA, naturally, in order to get to optimal solutions and get us toward our vision of 000.
Thomas, you want to add something?
So it's hard to add something. That was already more or less the whole story. Maybe just one additional remark. I already mentioned that maybe we will see 2 main streams. So one mainstream will be still in the individual cars with level 3, level 4 features. So for example, the highway pilot, the developed parking functions. But the other mainstream will be, to some extent connected and automated mobility concepts. And it's really hard to guess how successful that will be. So when we have a look at the Ubers and the Lyfts, especially in countries like China, that's the Didi, it's even impossible to get a normal taxi nowadays without an app. So I tried this in Beijing for 1.5 hours. I couldn't get a taxi because I didn't have the Didi app. So that's not a joke, that was very painful.
Good. And on that point, maybe a small discussion, because we want to say it more explicitly. level 3 personal owned vehicles will definitely be coexisting with level 4 and 5 shared autonomous vehicles. Because let's say the cost and the complexity between level 3 and level 4 can be so substantial. And so cars, level 3 personal owned cars are already on the market today. General Motors happens to make the only one that is a true hands-free system on the Cadillac Super Cruise. Those customers will really appreciate that they can use it, even if they can't use it everywhere for every condition. It makes a lot of driving conditions much, much more pleasant and less irritating for congestion and freeway driving and things like that. Shared autonomous that we talked a lot about will reside in the cities and in many cases be ring-fenced for certain geographic areas. And these cars will be interacting on the road systems together with, of course, the car park of level 0 and level 1 and level 2 cars. So I think that's pretty clear. I mean, we can't predict everything about the future, but I'm pretty certain that that's not a far-fetched example.
Great. We'll take one last question, comment. Yes, Bala?
So, a question to Dan. You shared us about the forecast until 2050. So it seems to be very conservative forecast. So when the governments are putting a lot of restrictions on CO2, there's a CAFE limits are going again and again, very tighter norms. And in this scenario, do you think that this forecast is sufficient to meet the CO2 targets? Even today, even in India, so industries are forced to apply more than 10% of EVs in the lineup. So in that scenario, so do you think that this forecast is optimistic?
Yeah, that's a great question. First of all, I'm just checking my graph again. What I showed was something from the Energy Industry or Information Association. So as I pointed out, that was not my prediction of the future. That was merely a projection from the EIA. And if you looked carefully, just to be clear, that was a projection for the US market with such a high penetration of gasoline, not for the globe as a whole. So you ask, how can that graph be compatible with CO2 targets, which implies, of course, that there's CO2 targets to begin with, which is very important to reduce. So it's frankly probably not really compatible with what needs to be done for sustainable mobility. That's why I don't really think in my world of peaceful coexistence, that's not actually the future that I'm thinking will happen, but it's actually really hard to find anybody that will make a prediction between 5 to 10 years, because usually all you can be is wrong. And what's really important for the FISITA World Congress and for all the engineers here, engineers create the future that we want by working together and cooperating. So if we don't want in 2050 a world that is still 85 or 90% gasoline vehicles, then we've got to work together and be innovative and really create the future that we want. Of course, it's not just engineers in industry, it's, as I talked about, academia and government working together, so we've got the right rules that actually allow and support innovation and great innovative ideas, rather than sometimes stifling creativity. So I believe in a world with 000. I don't know, which mile we're on the marathon. We're not yet at 36 miles with only 0.2 of a mile to go. We're somewhere in the beginnings parts of the journey. But hey, some people would take a day to run a marathon. Other people do it in just almost 2 hours. So it's really about how we train and how we are aggressive in making that come fast. So I would encourage everybody in the room, let's run as fast as we can to get to the end of the marathon with 000, because that's the world we all want to live in that we can create together.
Dan, that's a very profound and practical statement, and also a mission and vision for the engineering fraternity, I would say, just not in this room and not in the mobility fraternity, but across the different segments. So before I close, any last comment that you would like to pass on to the audience here? Thomas, you go first.
Just very briefly, it's late at the day. I just want to mention that I'm very honored. I'm pleased to be here, that I was invited to join the plenary session. So I hope that you had also some, I would say, good takeaways from the presentations today. And yeah, it's always a pleasure to be in India, honestly. Thank you.
Thank you. Any last comment from you, Dan?
Yeah, I just want to thank the audience for their kind attention and really the great attendance at this plenary session. Thanks for so many of you to come out. And really, we wanted this conversation to be thought-provoking and inspirational for the future, because we can create the future together. But at the same time, I'll just hearken back to the bumper sticker that I showed at the end with the peaceful coexistence. So please, the last thing we need is kind of a war between, oh, internal combustion engines are great, no, electrification great, and the other one's bad. We're going to be in peaceful coexistence for a while. So we should live in harmony and create the future together.
Thank you very much, Dan. Thomas, thank you, ladies and gentlemen. It's been a very, very informative session. Big round.
Hello. Thank you, Dr. Arun Jaura, for this wonderful panel discussion to chair this session. May I request Dr. Arun Jaura to present memento to Dan Nicholson, Vice President, General Motors, United States. Dr. Arun Jaura, I also request you to present memento to Dr. Thomas, Vice President, FEV, Germany. I request Steering Committee Chairman, Dr. Arun, to present memento to the Chairman of this session, Dr. Arun Jaura. Gentlemen, there's an announcement. Please join us for the entertainment scheduled at 7 o'clock in this auditorium, followed by the networking dinner. Thank you.